Hello and hi, my name is Hani Hardiana binti Zaharuddin, which no metric is E20A0335 from program Geoscience SEG. Okay, so I will choose the Boyle's Law experiment. According to a Boyle's law, the pressure of a given mass of an ideal gas is inversely proportional to its volume at a constant temperature. So, the purpose of this experiment is to determine how the pressure, volume and temperature were related in a gas.
Here I will show you the simulation of the Boyle's law experiment. Okay, we have a pump of the particles here, the pressure and also the temperature. First, what we need to do is I will pump in 50 large particles into the container, the large one. Okay, then I will set the temperature as a constant because in the definition of Boyle's law experiment, its temperature should be constant. And then I will turn on the width to show the width of the container. Okay, now I will adjust the width to 5 nanometer. Okay, now I can reading the pressure here. Okay, since the pressure is always changed, so I will take the average between the largest and the smallest one. Okay, let's see here. The largest pressure is 12.1 and the smallest one is 11.2. Okay, so I will show the data later. Okay, next we move to the 10 nanometer. Okay, 10 nanometer. And then I will reading again the pressure. Take the average. And then we move to the 15 nanometer. And then I will read again the pressure. Here, take the average, okay? Okay. Next, I will move to the other step to show the small particles. Okay, so I will reset again. I will do the same like before, but we do for the smallest one. Okay, I will reset again. Okay, I will repeat the step, which is we use 50 particles of the small particles. Okay, then I will set the temperature as a constant, and then turn on the width. I will do for 5 nanometer first. Okay, here I will keep reading the pressure here, like before, and take the average, okay, between the largest and the smallest one. And then we move to the 10 nanometer. Okay, then read again the pressure here. And the last one I will do for the 15 nanometer. And reading the pressure again, take the average, okay? Okay, that's all for the simulation.
Okay, here this is a result based on the simulation, and this is pressure that I have record and take the average. What I can tell here, the kinetic energy is directly related to the temperature. In Boyle's law, the temperature is held constant, so the kinetic energy of the molecules is a constant. The pressure and the volume are inversely related in Boyle's law. What happens in Boyle's law is that the molecules are forced more closely together. The more densely packed the gas molecules are, the more often they will collide, creating more pressure. So here we can see the volume is increased while the pressure decreases. So if the volume is greater, the number of collisions and pressure will be less. So that's why volume and pressure are inversely related if the temperature and the total kinetic energy is kept constant. The result here show the large particles and the small particles have the same pressure. Why? This is because matter in each state exhibits distinct characteristics. So here is a gases do not have a fixed volume or shape. As a result, gases respond to pressure changes by changing their volume. In other words, gases are compressible. Boyle's law describes the relationship between pressure and volume at a constant temperature for a fixed mass. Mean here, when the temperature is a constant, then the number of molecules of a gas cannot be changed.